my boots on and lace them up. Hard work, not another day's work. Hard work, hard work.
You can't cover all of agriculture. So I'm going to leave out large chunks of things today, but I hope that I can give you enough that it will interest you and tell you a little bit about what the land grant system is all about, and a little bit about what we do here at UMass. Is this my official clicker?
I hope so.
Let us try. Where's a click? Click forward. There. Okay. The first thing about agriculture that I think is pretty profound is that it's so central to human life on Earth that we've gone from being hunter-gatherers to being to really shaping the earth. I have a quote here. It says, since farming began, cultural evolution has gradually transformed Homo sapiens from a species evolving in response to the natural environment into one that is literally making the world in which we live. And part of what I want to talk about today is some of the profound ways that we've done that. If you look at the landscape, you can see this. And I'm just talking about agriculture. There's a whole chunk that I'm going to leave out about turf and ornamental horticulture that we also do that has just as profound an impact. If we look over the years, there's another interesting factoid I found here. After many millions of years living in groups of dozens or hundreds in mere 10 millennia, 10,000 years, we've changed the world so much that we now must adjust to living in a group of 5 billion. Well, the quote says 5 billion. We're up to 7 billion as of 2013. And this slide that I'm showing you here is a slab of the Amazon rainforest. And this is taken in 2000. And if we look a mere 9 years later, that's what's going on. So this process of transforming the world is still going on. It's still going on in a big way. To give you another angle on this, there's he's now a professor emeritus at University of Virginia, William Reutimann, and he came up with an interesting theory that agriculture is actually the major contributing factor to the rise in CO2 that we see now. His theory basically goes that if, I'm not sure, has this got a laser on it? There, okay. That, stay, do not fall. That if the trend that had been going on for millennia were to have continued, we should be in a cycle over the last 10,000 years where the level of CO2 in the atmosphere would be dropping. But we see it around 8,000 years ago from the ice cores that the CO2 level is going up. Now, obviously, 8,000 years ago, we're not running around in cars, we're not burning coal. Something else is going on. And the something else, Reutimann hypothesizes, is agriculture. Clearing land from forests, getting rid of trees, and then, perhaps just as importantly, planting rice. Rice generates a tremendous amount of greenhouse gases. And those things combined, he says, have contributed greatly to the CO2 level that we see now. Now, obviously, fossil fuels are going to boost that even further. Here's his unhappy predictions for the future that we see. This is what should have been going on, this is what has been going on, and then recently, this is what's going on. So agriculture, even from the early days, has had a profound impact on everything that we do. A little more recent example comes from the Dust Bowl. How many of you folks got to see that Ken Burns special? Great thing. The Dust Bowl occurred primarily west of the 100th meridian in the drier part of the U.S. And it was stimulated in part by something we're going to talk about in a minute or two, the free government land, the Homestead Act, and several acts that went with it. And when people were going out to settle this relatively dry part of the world, the weather cycle was wet. And so they were able to go and do the sort of European agriculture that had been adopted in America that they were used to, plowing up everything, changing the prairies into production systems. And that eliminated the native grasses, to make a long story short, and in about 1930, that long period of wet weather ended and a drought period ensued. And during that whole time, there was a tremendous change in how people were able to live. That was this is just one picture that's from the Burns thing. This is another picture, a famous one by Arthur Rothstein, looking at a half-buried house. Burns asked the question: is this one of the is this the worst man-made ecological disaster in history? It certainly is right up there. Dust storms as far as Washington D.C. from this, grapes of wrath, the people moving off of farms that were no good to California to work in the fields there. Eventually, over that period, the New Deal, many of the New Deal programs came along. One of those was the Soil Conservation Service, which is now the Natural Resources Conservation Service, and which we in the land grants have tight affiliations with. We work with them pretty closely. Well, the Dust Bowl we've recovered from that through programs like the conservation, replanting prairies in some places. But the next move was to tap into the Ogallala Aquifer. So if you're flying over the middle of the country and you look down in that part of the country, you might see something like this, where these big irrigated circles, where they're pumping water out of the ground, water that's been there for millennia, and now they are the water level has literally gone down.
Great timing, Naka.
Dust Bowl.
Makes me dry just thinking about it. So, I want to switch from that to back about 200 years to Thomas Malthus. And here's a quote of his about his doom and gloom. His basic idea that Malthus had was that population grows exponentially, and our ability to increase agricultural goods at best increases arithmetically. And so if you go along on those two lines, eventually you reach a state where there's not enough food to go around, and as a result of that, then some portion of the population is going to die, suffer. It's bad news. More recently, getting on towards 50 years ago, the Club of Rome came out with this prediction, and who remembers the limits for growth or has run across the limits to growth? What's that all about? Do you who remembers what? Better yet. Well, the limits to growth, it was basic. The Club of Rome had a model that they ran through, and they said, well, look, if present trends continue, we are going to be in a bad way at some point in the middle of the 21st century. And there was, at this time, this was when, I hate to admit this was when I was an undergraduate, and there was a lot of that doom and gloom sort of thing going around. Oh, we got to do something to save the earth. And that's basically one of the reasons that I got into this line of work, was that was what I was going to do. And I was successful, as you see, at this point anyway. So anyway, I'll come back to that point about the Club for Growth and limits to growth. But so far, so good. We have succeeded in sort of dodging the Malthusian bullet, if you will, up to this point. And you can see here on these two graphs that starting about, when is that? About the 60s and 70s and down here in the 50s, you see the real rise in corn production. Wheat, we have not had quite the same level of increase, but thanks to things like this, plant breeding, certainly in the 40s with the introduction, 30s and 40s, the introduction of artificial nitrogen fertilizers. And then another spin-off of World War II from the chemical industry, pesticides. They discovered that a lot of these things that they were using to make artificial rubber with, for example, could also kill potato beetles, and so pesticides came out. New machinery, new ways of tilling and taking care of the fields themselves, new irrigation methods, a lot of new technology in that respect. And of course, the Green Revolution that was focused primarily on the Third World came along in the 50s, and that was successful in saving places like Mexico and India, which were really looking at dire circumstances in terms of food production in the 50s and early 60s. All of a sudden, those problems disappeared. Now, in contrast to the Malthusians, and Mike, if I'm wandering around too much, you can yell at me. The Malthusians, the cornucopians are out there. There's a I've got to look at this in my notes here to make sure I get it correct. That, let's see, glasses. What did I do with them? Now we're in trouble. A guy named Julian Simon. He had a bet with Paul Ehrlich. Anybody ever hear of the Ehrlich-Simon bet? That they had a bin of goods, things like everything from gold. I don't know if oil was included in it, but there was a list of things. And the bet on Ehrlich's part was that the cost of those things would go up as resources became scarcer and population increased. And Simon bet, no, technology is going to take care of all this stuff, and in fact, it'll stay the same or go down. And in fact, Simon won that bet. So over the periods that they were doing it, it's still not an ongoing thing. And but anyway, there is this whole school of thought that says that the cornucopians saying, no, technology is going to be our saving grace in all of this. Well, I would argue that up to this point, really, in terms of food production, the land grants have made perhaps the major contribution to food stability in the world. If you look at this is actually the campus at the University of Minnesota, and in the foreground there, those are wheat plots. They're looking at the resistance of wheat to diseases, probably stem rust in this case, one of the stem rusts. And I show you that not only because I'm a plant pathologist, and I like to brag about plant pathologists, but the man who started the Green Revolution and really was a champion for working on crops for the Third World, Norman Borlaug. His mentor was a guy named Steakman at the University of Minnesota. Borlaug went to the University of Minnesota. Then he went to DuPont to work for a chemical company, and didn't like that. And Steakman and others sort of nudged him and said, you ought to go and work on something more important than that. Go. And he ended up going to Mexico, breeding wheat varieties, the Green Revolution varieties that ended up solving the famine problems that were about to burst on the world in places like India. So that's where it came from. That's where the Green Revolution comes from. That's where a lot of solutions come from. This whole system of land-grant universities, which I'm going to tell you a little bit about, is funded by a combination of both state and federal dollars. And in many states, not so much Massachusetts anymore, county local dollars. This system is really the envy of the world. I've traveled to other countries. I remember being in Romania in the 90s, right after Ceausescu had been overthrown, and talking to they had ag scientists there. In fact, ag scientists that had collaborated with people in the U.S., and so they were aware of the system here, and they said, we really have to put something together like this land grant system that you guys have. This is the thing that really is going to help us to produce. Well, I'm going to crank back the Wayback Machine a little bit here and talk about the history of the land grants. And it started, if we look at the period of time when the land grant started in 1860, at that time, about 11% of the population had the equivalent of a high school education, and approximately 3% actually made it through some form of college. Now, what do you think the levels are today for those sorts of things? How about high school? How many people are we making it? A little higher than 80. 85. It's about 85. How about college? No, actually, it's only about 35. Yeah. So that graduate, right? I mean, we start a lot more. Anyway, at that time, higher education was dominated by private universities, and they were primarily to educate, well, at first they were to educate ministers, but then physicians and lawyers and those sorts of professionals. There was some debate about whether public funds should really get involved in higher education at all in Congress. And it pretty quickly centered around this issue of states' rights. And of course, states' rights was going to be very important in the 1860s. So another 85% of the people at that time were living on farms or lived in rural population, were in the rural population. There were really three parties. The Whigs, which were sort of the predecessors of the Republicans, were fading out, and the Republicans were coming on. They were the new exciting party. They were the things were happening with the Republicans. Most of the Democrats, you probably know, were in the South, and they were sort of the descendants in a way of Jefferson. They were the agrarian types. Yet, ironically, those same people were the ones that were against public agricultural universities. They didn't see that as something that necessarily should be started at the federal level. So they said, no, we won't go with that. And eventually, those states' rights issues culminate in the Civil War. And it turns out for the land grants that was a good thing. While the original idea had come along in the 1830s that we ought to have these public agricultural colleges, it kept being shoved back by the congressman from the South who said, no, aren't going to do it. Well, when they all left precipitously in 1861 and 2, Justin Morrill took up the torch of introducing this idea of the land grant universities, of public agricultural and technical universities. So it wasn't just agriculture, it was also for the mechanical arts. Morrill himself was a Vermont senator. He was a mover and shaker in the Republican Party and had been in Congress for quite a time, and they thought, the Midwesterners who originally came up with the idea of the land grant said, well, let's have an Eastern senator push this thing through, and he was pretty successful at doing that. And he suggested not only should there be the mechanical arts and the agriculture, but let's put a military component in here as well, because we're going to need people to fight in the Civil War. And that package went barreling through. It was paid for by giving each state a chunk of federal land, which was then sold in order to take the money and build the colleges. That was signed, the Morrill Act, in 1862. So if you go to almost any of the land-grant universities, you'll find a Morrill Hall. We have a Morrill Hall here. There was one at the University of Vermont, and every place I've gone since, there's a Morrill Hall. It was not just to help out agriculture and to push it, but it was also this idea that it was public, that it was for the average person. Because as you see, if 85% of your people are living in rural settings, the average person is tied in with agriculture, and so one went with the other. And oftentimes the farmers, the people that were industrial workers working in the new factories in places like Lowell and Lawrence, they were the industrial workers, the mechanics, and they would also be in on this whole thing. Lincoln was instrumental in getting it done, and this document over here on the side is actually the first land grant homestead or a homestead claim that was associated with the Land Grant Act. Lincoln also established the Department of Agriculture. At first it wasn't a cabinet level position, but it soon became that. This Homestead Act opened up lots of federal land to settlement, and agriculture was booming. In fact, Massachusetts at that time, and the rest of New England, is really quite rural. This is a drawing of the Mass Agricultural College. I think this is about 20 years into the building of the campus. There's some older pictures that have fewer buildings, but you can still see the chapel. This is the Stockbridge House, which is where the faculty club is now, and I think that is the East Experiment Station. Everything else is down, but this is the original campus, the land grant for University of Massachusetts. In Massachusetts at that time, we had about 65% of the land devoted to farming, 38,000 farms. Hardly can conceive of that these days, because today we have about 10% of the land in agriculture, or farming agriculture, and 7,700 farms. In 1863, the Massachusetts legislature agreed, yep, we're going to build a mass agricultural college, by God, let's go for it. And but there was a big debate. Are we going to have it in the East or the West? And this has continued ever since I've been here. You may wonder why the med school is in Worcester. Well, same sort of debate. There was a debate, should it be associated with Harvard, Amherst, Williams, or what? There was also a side debate, are we going to put both engineering, the technical part, and the agriculture together? That eventually got resolved that MIT is actually our engineering part of the land grant situation in Massachusetts. Harvard, Amherst, and Williams either lost out or decided not to go for it, and what happened was that actually one of the people that was very influential in Amherst College, William Clark, also was instrumental in getting a separate college going, the Mass Agricultural College. This fine building is the West Experiment Station, and I put it here to represent a second part of this agricultural research program that was being developed. You see, it came later. It was the Hatch Act, and the Hatch Act was going to fund research. It wasn't enough just to say we're going to educate farmers, we're going to educate the average person, but we also want to do research. We want to innovate and discover. And so most of those experiment stations are tightly woven into the fabric of the land-grant universities. However, there's a few exceptions where they aren't actually on campus. One of the better experiment stations in the country is its own campus in Geneva, New York, which is about 60 miles north of Ithaca, where the college is. Connecticut has a completely different organization down in New Haven from the University of Connecticut, which is at Storrs. And they actually have quite a rivalry, or have, over my tenure. Somebody's nodding here. The third piece of this three-legged stool, as it's often characterized, was extension, which was started, yay extension. Smith-Lever Act of 1914. The motivation there was that even with this research, even with this education, information was not flowing out to the farmers at the rate that that people wanted it to occur. These innovators thought should occur. And so they created this way of educating that was based in the counties, that was based locally. And there was the county would fund some of it. The agents, the people that were doing the teaching, would live there, and they would go out and actually do the teaching, but they would do it with knowledge and materials and information and training that they were getting from the universities. This is one of the sort of summarizing quotes, if you will, from Seaman Knapp, who came up with a way of, really developed a way of demonstrating to farmers what was going on and proving to them that they could do these things with hands-on and convincing them to adopt them. The way he did it was actually his original demonstration that totally impressed Congress, was to solve a boll weevil problem in Texas in 1904. So the boll weevil was busy doing its thing, and they had some ways that they could tackle trying to keep it halfway under control, but the farmers weren't adopting it. Knapp did demonstration plots with farmers. So, you convince some farmers, just try this on a small place. They did. They were convinced. Other farmers would come in, boom. Very effective way to teach people. Another of the people that was very instrumental in getting extension going was a guy named Kenyon Butterfield, who was president here at UMass Amherst for 1906 to 1924. He really was largely responsible for getting the money put through Congress. He was really into the big things like fairs out in the counties and demonstrating to people that way. He would have organizations and clubs. He liked 4-H, the idea that we would have clubs of kids that were learning about all this agriculture out on the farm.
Woo! Sorry,
Yeah.
I'll stop.
No, that's.
No, I was a 4-H kid and an extension.
Are you a 4-H kid?
I was 10-year 4-H'er, and my dad was an extension agent in Ohio.
Okay. So tell no. Well, what give us a 4-H project?
I raised chickens. I raised cattle. I did my first computer project. Did a little programming basic in 4-H. Learned to make clothes. Learned how to calculate the cost per cookie of a batch of Snickerdoodle. People have been asking me ever since how I got the early public speaking experience, because at one point Cornell called and said, "You're not on our radar. Your county in Appalachia is not on our radar. How'd you end up doing this?" And I said, "Come on, guys, you're the land grant institution, 4-H."
Absolutely, it's great. It's a great institution. So this is just sort of a representation, my concept of how all knowledge flows out. Actually, those should not be one-way arrows rather. There's a lot that comes back that's important that gets missed if you look at those as one-way arrows. So it's an exchange. And so this was really the last piece of the primary piece of the three-way stool. But there is one thing that's come along since then. I just put this picture up because I thought it was cool. this beetle is literally loaded up with a larvae of a parasitic wasp. So they've just about eaten it all up from the inside, and then they're going to come out and they're going to be running around getting more flea beetles, biocontrol. But anyway, this is one of the many sorts of things that the ARS does, the Agricultural Research Service. And this was started in 1953 because at that point, most of to some extent, the states' rights was continued in a way because while land-grant universities would collaborate, there was also a lot of rivalry, and sometimes that got in the way of actually multi-state collaboration. So they started ARS to try to deal with some of these problems on a federal level. And in many cases, the ARS labs are associated, again, with the land-grant campuses. Others are independent. Probably the mother of all ARS labs is in Beltsville, Maryland. The National Ag Library is there as well. But there are many, many all over the country. This map I just want to show you quickly. This shows the 1862 institutions. Since that time, we have the traditionally black institutions that have been added to the system, and then most recently the Native American institutions in a few states have been added to the system as well. But you see each state has its own main old 1862 institution. Over time, we've evolved. So if we started here, this is we have a good example, but this is the same sort of thing that's happened in most other land grants. We went from being an ag college to being a state college. So you see the generalization from being just agricultural to having other things going on. Then it became the University of Massachusetts in 1947 with a College of Agriculture. That college became the College of Food and Natural Resources in 72. Then it became the College of Natural Resources and the Environment. No more agriculture. Most recently, we are part of the College of Natural Sciences. Many other non-agricultural departments in the College of Natural Sciences. Primarily, our agriculture is in what is now the Stockbridge School of Agriculture, and then Extension and the Experiment Station are in the Center for Agriculture. So that's how things have evolved, and you can see both the land grants all over the country have generally gotten bigger, much broader. At the same time, in places, particularly in the Northeast and more urban states, then at least the percentage devoted to agriculture has decreased. In often cases, the absolute resources have decreased. In some ways, that makes sense. There's a lot fewer farms in the United States these days. You can see during the last part of the 19th century, people moving west, farmland expanding, more and more farms, and then in the 30s and then 50s, things start to decrease quite a bit. The percent of people living on farms dropped tremendously. We go all the way down from, remember, there's a rural population of 85%, of which about half are living on the farms, and that drops down to today where roughly 1% of people are actually directly living on farms, and in many of those cases, that's a part-time gig, okay? You're also, at least some people in the family are working elsewhere. Interestingly, our land in farming has not decreased that much. In fact, our production, remember this is this old graph, our production per acre has gone up. And as a result of that, we're producing as much as we have ever produced in this country in most basic agricultural commodities. Many cases, just tremendous amounts more than they ever were in the middle of the 19th century. However, getting back to our problems with the environment and with population, we're sort of maxing out in many ways. If you look at this globally, about 40% of the Earth's land area is used in agriculture. Remember Reutimann? Part of that, part of what we do is a major contributor to greenhouse gases today. The intensification of agriculture, irrigation, pesticides, fertilizers, those sorts of things, and our use of energy really has made it so that while we can produce more than ever, we're also using a lot of resources in order to do that. And many of us think that this sort of production is not sustainable. That in the long haul, it's going to break down. This is a kind of mind-boggling statistic. Farming uses 3/4 of all the water that's used for anything around the world. Huge. Here's another thing. If we look at world grain production as sort of an indicator, we see, yeah, going up quite nicely since the 60s, chug, 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 but population is going up more quickly, and so if we take that production and measure it as per capita, in other words, bushels of grain per person, then that has sort of leveled out and sometimes dropped down, so that right here we've sort of reached that Malthusian crux, if you will. There are some issues. Going along with this, you may remember in the last 5 years or so, there have been all these spikes in corn prices, spikes in onion prices, spikes in all sorts of agricultural products in terms of their prices, which is simply an indication that supply and demand, people are paying more for food. Well, work to do, new problems to solve, and to do that, the USDA has renamed what used to be the CSREES, the Cooperative State Research, Education, and Extension Service. And that was the big umbrella organization in Washington that included all these things that I've been talking about. Now we are NEFA. And one of the reasons that we are NEFA is that just a name change alone they thought would help in terms of putting us on equal footing with, say, the National Institute for Health. And I think in some ways it has. There's been reorganization associated with this has been very positive in terms of stimulating both research and extension and on-campus education. This is the home for all of those programs now. In fiscal year 2012, $1,358 million going into those sorts of things. So that's not, those are not farm subsidies. That's the dollars going into the universities, the research, and all that sort of thing. That's a good-sized chunk of money. I see the problems that are out there as sort of, agriculture has always emphasized productivity. In this country, from the days of Earl Butz, get big or get out. We've thought bigger farms that produce more on a per acre basis, that's the way to go. I think that when we look, we're now able to see some of the sustainability issues that are occurring because of that. We realize that there's a conflict with the environment and that this conflict has to somehow be resolved. One of the solutions that has been proposed by these folks down here, this is a paper that was in Science back in 2011. They have like 4 points, and this is one that I think is most salient. Don't get hung up on types of agriculture. Okay, don't worry about whether it's organic. Don't worry about genetic engineering per se. There may be some issues there that we need to explore, but let's not choose sides and get all hung up. Let's look for some combination of things that is going to be able to keep both the environment and our production of food sustainable. So here's a pop quiz to sort of wake people up, I guess. What's the answer to that? No. And why not?
Because there are, I guess, pesticides considered organic or biocontrol methods. I don't know. How do we define pesticide?
Well, there you go. Let's say a pesticide is anything that can kill I'll narrow it. Any chemical that can kill
predatory wasps.
So predatory wasps are out, right. So your answer is right. There are different kinds of chemicals that are used in organic agriculture. The key feature of those being that they are produced naturally. That is, they are natural minerals. That it's not something that has been synthesized off in a plant in Delaware. Okay, that's an easy way to look at it. Actually, organic agriculture was originally anyway was more concerned with the health of the soil than it was pesticides. But today, I think a lot of times organic is used as a quick and dirty way when you're running into the supermarket at the end of the day and you're frazzled and you want to buy good food and you don't want to get the nasty stuff. Then that's a quick way to say, oh, organic. I'm going to grab that and I'm going home. So anyway, it's a more complicated issue than that. NEFA has identified research emphasis areas, and you can go down that list and you can see this is I just put this up. When I look at librarian, I think, my God, giving people who are doing agricultural research resources in the sciences, there's the waterfront. I mean, that's just all over the place. Economics, anything. My favorite down here, we have pest management is one of them. Agricultural systems are important. But remember bringing these things together. So in other words, if you're going to do research, I think NEFA is doing a good job saying we need to look at everything. So in the ag systems area, they have sub-areas that they fund research on, which includes organic. It includes sustainable agriculture, obviously enough, has other things in it, manure and nutrient management. But over here, in this other area, we have biotech, microbial genomics, breeding, and those sorts of things. So NEFA, at least, in the land grants, is looking at all options. Another proposal from Foley and that group was to identify leverage points in agricultural systems that will be easiest to influence, okay? Things that you can change that will be best for the environment but maintain or increase productivity. So another pop question, what is an agricultural system? This is a little tougher, no easy answer.
Like production to consumption?
I like that, production to consumption, because I think that we tend oftentimes to just think of, okay, it's a farm or it's a group of farms, and so that's all it is. But I think it is more than that, and so I'm going to take a few minutes to follow up. If we look at things very simply, these are examples of some simple agro ecosystems, okay? Crops that we directly eat, crops that we feed to animals and then eat the animals. Maybe we graze the animals and then we eat the animals. Maybe we use both and then we eat the animals. And more people are eating animals. I think that's going to be something that's going to have to change. Simply because once you go through each level, it's much more expensive to get calories that have gone through an animal than it is to directly eat those calories. If you look at an agroecosystem in detail, then you have a little more detail. I mean, there are some diagrams out there that look like Rube Goldberg on crack or something. It's just like lines all over the place. But this is a simple system, and I want to look briefly. Well, here we have inputs. These are some of the main ones going into the system. There's some natural nitrogen fixation. Most of all, what we're doing is capturing solar energy and then using that to fix nutrients that we need. And then there's obviously waste, and those things go out for our use. I'm going to focus on just one of those inputs for a bit here. This character is one of my mentors, perhaps my most important one in many ways, a guy named Ron Prokopi. And at that point, what he's doing, he's fixing his Volkswagen bus as he goes through what was then communist Poland and Czechoslovakia, because he'd gotten fed up with the Connecticut Ag Experiment Station because they just were not moving fast enough to take care of what we needed to do for sustainability and pest management. And so he had a nice job at the Ag Experiment Station, took off, said, no, thank you, I'm going to go do other things. I want to see what they're doing in Eastern Europe. I guess he just couldn't get to Cuba at that time. It was too tight. But anyway, he was looking around different things. One of his key points was that and this was especially true when he was growing up in the 40s and 50s, we were into controlling nature. We were orchards, for example, the places I worked, they had to be squeaky clean. No diseases, no insects, no nothing. It's sort of the 50s housewife syndrome, except taken over by the farmers. You know, everything has to be clean and neat. Ron always said, no, that in the long run, that's not going to work. And he had seen it break down. Pesticide resistance developed in mites that fed on apple trees. So from the grower and production point of view, resistance was the big thing. Of course, in '67, along is going to come Rachel Carson, and then society as a whole is going to get onto it and say, hey, wait a second, we're busy killing off our predatory birds, and among other things, and we need to do something about that. So by the 70s, when Ron was finishing up with his stint in Eastern Europe, he was into this whole idea, which was then a new idea, of integrated pest management, IPM. And here's Ron doing exactly the same thing that Seaman Knapp did. He's out in an orchard demonstration explaining what's going on in terms of, to a group of growers in terms of pest management. So this integrated pest management concept was a way of getting off of the pesticide treadmill. Pesticides had been identified as the solution to all insect disease, weeds, you name it. We got a chemical for you to deal with it. And it was leading to both the environmental and resistance problems that I was talking about. The basic idea of integrated pest management is that you only use any sort of control, whether it's a chemical or not, when you need to use it. When there's an indication of a high risk or that something's going to happen if you don't employ it. You're constantly looking at what's going on in terms of your crop and in terms of the pest to determine that need. And there's lots. We taught a semester-long 5-credit course on IPM, so I'm not going to be able to give you that today. but so there's lots of ways to do that. But that's the basic approach. You use a full set of tactics and not just pesticides. So if you take that, you can make a diagram out of it, and let's look at some of those tactics. First, you have cultivar resistance. That is the plant's genetic resistance to diseases, to insects, to whatever. I've broken that down into major gene and minor gene resistance, and that's, again, another long story in and of itself. There's a set of cultural controls, things that we do like picking up the diseased debris that might have fallen down in your garden in the fall, planting rows further apart so that there's more air circulation. Lots and lots of different cultural controls. Biocontrols, think of that corn flea beetle. That's a biocontrol. Lots of other kinds of biological controls out there. And then chemical controls, the pesticides. There are different kinds of pesticides. As we said, there's organic pesticides, there's synthetic pesticides, there's some that are much more environmentally benign than others and can be used. Then there's this whole business, as I said, of observing, of monitoring. And so you might look at weather, you might sample and trap insects. You do an evaluation of what sorts of pests might be surrounding your site or what and might be in the site. And those are used to create thresholds and then to have models that will tell you how things are going to pan out, or we think things are going to pan out in terms of risk. And then if you need to, you can treat with something. That all hopefully limits damage. So Ron saw this IPM approach as part, this gets back to your point, that this pest management is part of the larger thing. And it's not just the agro ecosystem, but part of a larger food system, because you need to involve consumers. You need to involve policymakers. You need to involve everybody who is going to be both using your products as well as the people that are producing them. And that in order for those things to be sustainable, that you have to be environmentally and economically sound. For decades, for well over 100 years, most of what was going on in our ag research was focused on productivity and the economic side, and it was only through things like IPM that we were getting into the environmental piece. Now, to give you an example of why this is so, as you get into more what we call bio-intensive, in other words, environmentally benign approaches to management, inevitably those things are more expensive. It takes time to monitor. You have to. Oftentimes, the things that you're going to use for treatment, if the newer chemicals that are more environmentally benign are more expensive. You have to take time with some of the cultural controls. Anyway, it costs more to use these bio-intensive practices. In order for that to work, somebody has to pay the growers to adopt them, or else if there's another group of growers that aren't adopting them, they're going to be able to undercut you, and pretty soon you'll be out of business, okay? So there's both a carrot and a stick approach to it. We can have the government doing regulations as well as perhaps offering financial incentives. In addition to that, maybe we can get in the marketplace some extra money. That's why we pay more for organic, but it's difficult to identify this IPM stuff. One of the things that we've done here in Massachusetts is I work with a nonprofit vegetable and fruit wholesaler known as Red Tomato. And over the years, last 5 or 6 years, we developed this thing called Eco Apples. They do the marketing, and they stress local. And we've come up with a protocol of integrated pest management practices, biologically intensive IPM practices, that growers who produce Eco Apples have to adhere to in order to get their apples called Eco Apples. And they've done it. In return for that, the original idea was that they would get a considerable bump in price. The markets are tough, and that, while sometimes it works, it has turned out that what they are actually getting is access to markets that they didn't have before. So they can go to Whole Foods, they can go to Trader Joe's, they can go to places that want these sorts of products. And the price may not be that much higher, but they're selling more and they're happy with it. So the growers are happy to join in with it. So that's one of the ways that we interact to try to make this whole system work. And so I work with a nonprofit wholesale company that's not part of the land grant system, but we collaborate with them, and we have growers all over New England, New York, and down into Pennsylvania now that are cooperating with the project. Well, to sort of finish this up, that I think that part of the Jeffersonian notion of agrarianism, you know, the yeoman farmer was going to be the basis of American culture. That whole idea was that that was the best way to be educated, to be connected to the most important thing in the world, producing food. That was important, and that's what needed to be done. So I think that we need more of that idea today, but obviously with only 1% of the population actually producing food, we need to get at it in a different way. We need to build those connections in different ways. I'm not sure how that's going to be, but we certainly see there's some motivation to do it in local food movements and people that are joining CSAs and that sort of thing. New technologies will undoubtedly be critical to developing a sustainable agriculture. And I think really that the land grants are going to be at the heart of this thing. And we're going to need to come up with some new ways to broaden our educational reach so that more people understand what the land grants are, what their food is all about. And we're working on that. And I think we're having some success. Need a lot more, but we're getting there. So with that, I'll open it up to questions. Yeah.
Go ahead.
Would we do a microphone or on lights like
You have
that?
to holler. Just holler.
Mike, what should I walk up close here? Or what?
I would say.
I'll repeat the question.
Yeah, the best thing is to just repeat it through the microphone.
Okay, so I had sort of two questions. One was about the general consensus among agricultural scientists on patenting agricultural products like strain seeds, and then whether or not there was a general consensus among agricultural scientists whether or not that was a barrier for doing research. Because in the life sciences, you hear that some people might not want to be working in certain areas of the genome because they might be impinging on patented
Right.
areas.
I got you. Yeah. The question is, what is the general consensus among agricultural scientists in terms of patenting genetic resources? And is there, what was the second part again?
And the second one is that a barrier for people doing
Oh,
research?
is that a barrier to people doing research? In answer to the broader part of that, there's no general consensus among agricultural scientists about anything. So, but I think definitely that the patenting of genetic resources is an impediment. I can give you an example of that. The major disease of apples that around the world is something called apple scab. A researcher at Cornell developed a way to take an enzyme, a gene that produced an enzyme that breaks down fungal walls. And essentially it made, you could take that gene, put it into a Macintosh or an Empire, whatever your favorite apple is, and that would become resistant to this majorly important disease. Unfortunately, there were several steps along the way where the genetic resources in the process of getting those genes into the plant were tied up by other people. So even though he was able to produce the plant, he'd never be able to sell it and to get it out into the market. And so he just gave up on it. He said, no, I'm not going to do it. So it's definitely an impediment. I think that if you went around and polled people, you'd probably get a group that would say, no, this isn't good. We should liberate this stuff so that everybody can use it. And then another group that says, oh, no, the market is going to drive people to discover new things only if there's going to be some profit in it for them. My personal bias is that I think that there are some things that are so important that they need to be public, and I think plant genetic resources are one of those things.
I have heard anecdotal evidence that with the very, very tiny number of people who live on farms, and therefore a very small number of people who have come to farming from sort of a multi-generational viewpoint, we also, and with the influx of new people who are interested in slow food, local food, sustainable agriculture, who may not have come through these sorts of setups, because there's a lot of hipsters starting to farm.
Yeah.
I hear anecdotal evidence that when they go to organic farming days, they're like, whoa, man, this is new, when it's been reported in, it's stuff from agricultural yearbooks of the 1930s. Are you, this is my dad's retired extension agent, you young kids these days rant, but are you folks working, are folks working on how to make sure that we're passing on that information, and what are the best routes? Is it to try to talk these folks into taking some ACT classes, or?
Well, yeah, I mean, that's that. For example, here in the Stockbridge School, we have a program, Sustainable Food and Farming Program for undergraduates, and we have both 2-year and 4-year program. I would say 3/4, maybe even more of those students in the 4-year program are new to it. So that's one thing you can do. In terms of the people that just have, they bought a farm, they want to farm organically. That's a different thing, and they'll learn, and we'll do.
They'll fish or they'll swim or not.
Yeah, exactly. But there is extension has a new. I think probably at the NEFA level, there's a new farmer program, which is yeah.
New entry sustainable farming project.
Yeah, exactly.
Awesome.
And so for example, yeah, well, there's a lot of that going on. If you look at Massachusetts demographics, you know, you see the line going down in terms of numbers of farms until this last ag census, when all of a sudden there's an uptick, a little bit of an uptick. So people are getting back into it, and I think that's a good thing. Extension realizes it's a good thing, so there's more resources going into that.
From the policy perspective, where are they in terms of the government in subsidizing local farms over, like, why do we continue to subsidize corn and soy products so much more than fruits and vegetables? Is there a shift happening to sort of boost up this?
Repeat the question.
Yeah, the question is when or why don't we subsidize fruits and vegetables and small farms in the same way that we subsidize corporate farms that are producing corn and soybeans? And I think what's going to happen, and this is just my guess, who knows, is that there's one of the ways that they can cut the budget, which Washington feels it desperately needs to do, is to cut subsidies to the big farms. I don't think you're going to see subsidies then appear for small farms or for fruits and vegetables. I don't think that's going to happen. I think we're going to have to generate those sorts of dollars on our own by convincing people that it's worth paying for that local produce.
So somebody had to raise this. There's the whole GMO food thing. It's in the news a lot lately, and there's a lot of very strong negative reaction from the population to it. In my opinion, GMO, people treat it like it's one thing. It's actually many, many different things. And so my question to you is kind of two-part. One is, what do you see the impact of GMO practices on agriculture in general? And how do you view, I mean, GMO is not all good or all bad. How do you talk to people about it in a way that helps them make sense of it rather than having a knee-jerk negative reaction to it?
That's well put. I agree with you. It's not all good or all bad. I think forms of GMO are going to be critical to solving our sustainability problems. And I'll go back to my apple example. One of the same guy that gave up on one form said, okay, well, if I can't put that gene in, I will go take an apple resistance gene and I will use genetic engineering methods to more quickly move that gene into some of our standard cultivars so that we can more quickly have that form of resistance. Basically, what genetic engineering has done is just accelerated our ability to breed new crops tremendously. We've been breeding crops, in fact, unintentionally selecting crops since agriculture started. It's just that we have now, with the new technology, the ability to do it incredibly fast. And with that ability, I think, comes the risk that you're going to put something out there that's going to be a problem. And that we need to come up with some safeguards against that. What kind of problem? Well, it could be something where you have a mass. There's an example of a gene that was put into the corn genome in this country before genetic engineering in the hybridization process that made virtually 90% of the corn crop in the country susceptible to a rust disease. Just decimated the crop for 2 years. It's a great story, but I haven't time to get into it. But the problem, that was the lesson from that is that it's easy to do something unintentionally that would screw up either our production system. Hopefully, we have enough safeguards in place so we're not going to do things that interfere with people's health, although I know there's certainly a lot of people out there that think, I'm not going to eat a GMO because it's going to give me the hives or worse. So those sorts of considerations need to be taken into account. How do we talk to people? Well, you're not going to convince everybody, but I think you have. My way of talking to people is exactly what I just said. That this is the next step in something that we've been doing for thousands of years, and it's using our modern technology. And we got problems that are big enough that we're going to have to use that technology in some way or other if we're going to solve them. That's the way I see it. Because here's one final. Sorry, Naka, I'm revved up. There's the Club of Rome thing that I was talking about. There was actually a follow-up paper that was done in Australia about 3 or 4 years ago that looked at 30 or 40 years since that report had come out and said, okay, how on were their predictions? And this paper says that, in fact, their predictions were pretty on, that the sorts of things that they were saying would happen have happened. You may remember that a lot of this limits to growth stuff was pushed aside. Oh, look, it's not happening. You know, we're doing just fine. I more or less was giving you that line. But this paper says, no, really, those guys didn't predict that there would be really big problems until the middle of the 21st century. That was when the big breakdown was going to occur. And they, according to them, we're sort of chugging along on that track. So we got to do something different. One more?
Okay, you have 5 minutes.
5 seconds?
The decline in the bee population,
In the what?
bees,
Oh, okay.
How is that affecting agriculture, or is it, and can technology overcome that?
This is actually an excellent segue because I was just talking with Hillary Sandler about bees and cranberries and what they were bringing in.
Can you just repeat?
Oh, the question was, is the decline in pollinators, particularly honeybees, affecting agriculture? And if so, what can you do about it? What is being done about it? Lots is being done about it. It's definitely been identified as a problem that needs to be addressed. The first issue is what's causing it. The answer to that, it looks like a number of things, from pesticides to diseases like virus diseases, perhaps varroa mites are involved, but nobody has come down with a single thing that's doing it all. Hasn't been solved. But one of the answers that Hillary mentioned is that the cranberry growers, for example, are bringing in bumblebees. People are now raising bumblebees rather than honeybees because bumblebees are tough mothers. And so they will go out and work when honeybees won't. So and I have another colleague, Sonia Schloman, who's working on other natural pollinators, setting out nesting sites for those pollinators to enhance their populations around agricultural areas. So that's another thing. But definitely high in terms of priorities at NIFA and USDA.